to Combat Setup. Today I will talk about my research project. It's a project I work on subset sum problem. I use two different methods, one genetic and also add wisdom of crowds on top of it. In this, I will try to explain what is subset, sum problem, why is it hard, how my GI worked, how I added wisdom of crowds parts, and what experiment I did, and how GA and combination of GA and wisdom of crowds compare by using charts and CSV results. First, subset sum problem. We start with a list of numbers, for example, 1, 2, 3, 4, 5, and such on. And we also have target number, say T. And our goal is to choose some of those numbers that were given or listed so that their total sum is close as possible to T. Our project will only allow each number to be used 0 or 1 time. So for each number, I decided either take it or we're just gonna skip it. It's really simple to explain, but it's hard to solve exactly. When we have many numbers, huge data, we could need to check many combinations, and that's why subset sum is a classic NP hard problem. There's no fast or any perfect algorithm for all cases. So in this practice, I trying to use heuristic methods like GI, genetic algorithm, to find a good solution for that. My goal for the project, why I choose GI and WC, we can say the reason I choose GA and wisdom of crowds is because the genetic algorithm is good when we search space is large. We do not need to perfect answer, but we do want a good answer in a reasonable time. So GA works with population of solution. It kind of keeps improving themselves generation by generation, so it gets better over time. And the wisdom of crowds idea is sometimes if we combine the options of many good solution or the solution we want, we can get an even better answer. As we did in project 5, I already used GA with wisdom of crowds for the TSP. And in project 6, I want to see can the same idea help for the subset cell. So my goal is to kind of compare the plain GA and with GA combining the wisdom of crowds and see which of the gives a better solution. I will kind of explain how my genetic algorithm works. The representation, I use binary string to represent solution. For example, if we have 5 numbers, a solution like 10101, that means maybe take number 1 and skip number 2, and take number 3, skip 4, such on, and it continues. And for the fitness function, for each solution, I compute the sum of the chosen number. I will look at the difference from the target t, so it will be like a sum minus t. So if the difference is 0, the solution is perfect. Nothing wrong with it. And the smaller the difference, and the better solution it will be. And for the GI steps, uh, started with random population of these binary strings, and every generation I use tournament selection to pick maybe a better parent. Then I apply crossover and permutation to create a new children. I also kept a small number of the best solution from the previous generation, like the population size is 100, and the generation 300 crossover rate is 0.8, and the mutation rates are 0.05. Those are the things that I kept. So we can see here. For Wisdom of Crowns design, uh, after GA runs for all generations, I will take 20% of the best solution from the population. I call them like experts. So what it does is for each byte position in the solution, I will check how many experts have 1 and how many has 0. If more of the number choose was 1 at the position, then basically the best number were 1, and if more was chosen was 0, then it will be best answer 0. In this way, I kind of, it's like building one new solution from the crowd's majority votes. It's like voting. So whoever gets better vote then gets selected. And after I build this new solution, sometimes it might not be perfect. Uh, the result could be low or a little bit high. So I add a small repair steps. If the sum is too big, then I try to turn sum 1 or 0 bytes to small, basically turn sum 1 or 0 numbers with small impact. If the sum is too small, then I try to turn some of the 0 and 1s to get closer to the target. And in the end, I get like the combination of GA and Wisdom of Crunch solution, and I can compare it with whatever the best solution is on Gen GA solution. And for my data sets and experiments, I use auto-generated data sets. Here's the name of it and target. Each number is between 1 and 0. I mean 100. And the target T is about 50% of the sum of all numbers. And for each data set, I run my algorithm 10 times with different random seeds. In every run, I record the difference between the final sum and the target for playing GA. So it will be called GA difference. And the difference for GA and the combination of Wisdom of Crowns will be called the difference of Wisdom Crowns, and also the runtime in seconds. Then I was trying to comparing the minimum and the average and the standards division for just doing GA and the combination. This is basically the experiments that I was trying to do. And the results is, as we can see here on the right, the chart is the lines plot, and for data sets, the X-ray is the raw number from 1 to 10, and the Y is the difference from the target. The blue line shows the GA diff, and the orange line shows the difference on wisdom of crowns. And as we can see in the chart, the blue line is always at 0, all the way down to the end. This means GA is always find a perfect solution for the data set, but since the orange is moving upside down, up and down, so some of the runs has mistakes coded. So for the data sets playing, GA is very strong, but the combination with Wisdom of Crown is not doing any better. It has big mistakes, and sometimes in Wisdom of Crown steps even kind of made the results only worse instead of making it better. Um, Here's the table of running it 10 times. It's only showing 9 of them. I don't know where the last one went. The first, it shows the GA at the difference of the run times, like I said before. And for the data sets, GA has minimum difference 0 and average difference of 0, as we can see here. So the combination also has a mini diff of 0, but the average diff is about 11.6. And the runtime is similar for GA and the combination around 0.3 to 0.4 seconds per run. And the second table is the average difference of the combination. The first one is GA. This means that for the problem size, GA is very stable. The difference is always been 0 and the combination is not. However, in conclusion, this project, the genetic algorithm to solve the subset of sum problem and the ones that I combined with wisdom of Crowns idea, it designed a simple binary encoding of the solution and a fitness function based on the difference from targets. The GA operator was the torment selection, crossover, mutilation, elitism, and award wisdom of crown steps that takes 20% of the experts were all the steps and the ideas that I took over. I tested the methods on the auto-generated datasets with 50 numbers and targets equal to 50% of the total sum. And clearly the experience showed that plain GA already finds perfect solution in all the runs here, as we can see. And